So you have a function on the screen, and the function is x cubed minus 3 times x plus 3. So this is a given function, and from this given function, what we will have to do is we will use the first order derivative to find out the point of local maximum and the point of local minimum, and also to find out the maximum value of the function and the minimum value of the function. So if you look at x equal to minus 1, what we see is above the x-axis and just above x equal to minus 1, you will find that you will have the maximum value of the function. And therefore, x equal to minus 1 is called as the point of local maximum, because the value of the function is maximum when x is equal to minus 1. Now, x equal to 1 is called as the point of local minimum, because at x equal to 1, the value of the function is the minimum. So, looking at the picture, it is very easy to understand about point of local maximum and point of local minimum, the maximum value and the minimum value, but only when you have the graph in your hand. But the problem is, during exams, you will not be having the graph. So you will have to find all these points, all these values, simply using your calculations. And in this case, simply using the first order derivative. Now, before we proceed further, let us observe the nature of the graph at values closer to minus 1 and at values closer to 1. Because we are using the first order derivative, so we need all these informations. What we do is we take values very, very close to minus 1 in the first case. Say now you are taking a number between minus 1 and minus 2. Any number between minus 1 and minus 2. And then from that number, you go up, because there's no point in going down because the graph is upwards. So we go upwards. And when we go upwards, we will meet the graph at some point. So when we meet the graph at some point, then assume that you are drawing a tangent through that point on a graph, and that tangent you extend indefinitely. And when you do that, you will find that the tangent and the x-axis, they will make an acute angle. And when they make an acute angle, the slope is positive. Now, also assume that you are taking a number between minus 1 and 0. Any number on the right of minus 1, but a number which is between minus 1 and 0. In this case also, you imagine that you are going up because the graph is upwards. So imagine that you are going upwards. And when you go upwards, you will meet the graph at some point. So from that point on the graph, you draw a tangent. and that tangent you will extend indefinitely. So when we do that, you will find that the tangent and the x-axis from the positive direction of the x-axis, and you measure the angle, it will be an obtuse angle. So whenever you have an obtuse angle between the x-axis and the line, so the slope of that line will be negative. That we have learned in class 11. So we see here that whenever the slope of the tangent changes from positive to negative, then you will have a point in between, which is the maximum value of the function. Also, we do the same thing at x equal to 1. So imagine that you are taking a number on the left side of x equal to 1, a number between 0 and 1. Now, if you have taken that number, then we go upwards. Why we go upwards? Because we know that you will meet the graph only when you go upwards. So we go upwards, and when we go upwards, we meet the graph at some point. Now, when you meet the graph, you will have a point on the graph, and through that point, you draw a tangent to the graph and extend that line indefinitely. So when you do that, you will have an angle between the x-axis from the positive direction to that tangent. And you will find that in this case, the angle will be an obtuse angle. And you know that whenever you get an obtuse angle, the slope of the tangent will be negative. Now concentrate on the right side of x equal to 1. Say you are taking a number between 1 and 2. So when you are taking any number between 1 and 2, and say from that number you go again upwards. Why upwards? Because the graph is it is above the x-axis. So when you go upwards, it is very sure that you will meet the graph at some point, because the graph is a continuous graph, it is a continuous function. So when you meet the graph at some point, then again, you draw a tangent to that point and extend that line indefinitely. And you will find that the angle between the x-axis, the positive direction of the x-axis, and that tangent will be an acute angle. And you know that whenever you have an acute angle, the slope of the tangent will be positive. So the slope of the tangent changes from negative to positive whenever you have a minimum value of the function. So with these things, let us start. So the given function, it is x cubed minus 3 times x plus 3. So that is the given function. And remember, we don't have the graph in our hands. So what we will do is, we will find out the maximum value, the minimum value of the function, the point of local maxima or the point of local minima, simply using the first order derivative. So the first step that we need to do is, we will find out the derivative of the given function, the first order derivative. So the first order derivative will be 3x squared minus 3 times x, and that will be equal to 3 times x minus 1 times x plus 1. So f prime of x, or the derivative of the given function, is a formula to find out the slope of the tangent at any point on the graph if we know the variable x. So now our first step is to find out those points of local maxima or local minima. Now, to find out those points, what we have to do is we have to recall back of what we have learned last time. So whenever you have a maximum value on the graph, the tangent to that point on the graph will be horizontal to the x-axis. And when the tangent is parallel to the x-axis, always the slope is equal to 0. That means f prime of x is equal to 0. Also, when you have a minimum value on the graph, or the minimum value of the graph, what we have seen is the tangent to that point on the graph will be parallel to the x-axis, and whenever the tangent is parallel to the x-axis, the slope of the tangent will be equal to 0. That means f prime of x will be equal to 0 at that point on the graph. So now if we equate f prime of x equal to 0, that means we are trying to find out those points on the graph where you have the maximum value and the minimum value. To find out those points, we equate f prime of x equal to 0, and when we do that, we will be getting x is equal to 1 or x is equal to minus 1. So these are the 2 points, the point of local maxima or the point of local minima. Now let us find out whether which one of these is a point of local maxima and which one of these is a point of local minima. So with these 2 points, we will find out the maximum value and the minimum value. So let us first of all take the number x equal to minus 1. After that, we assume that we are taking a number on the left side of x equal to minus 1. Assuming that you are taking any number on the left side of minus 1, just a little lesser than minus 1. So if you have taken that number, substitute that number in the expression of f prime of x and find out the value that you get from there. So if it is greater than 0, it means that the slope of the tangent is positive. So if you're taking a number on the left of x equal to minus 1, a number little lesser than minus 1, and substitute that number in the expression of f prime of x, you will find that it will be greater than 0. The value will be greater than 0. And if you take a number just greater than minus 1, and that number you substitute in the expression of f prime of x, so you'll find that f prime of x is less than 0, which means that the slope of the tangent is less than 0. So here what we observe is the slope of the tangent changes from greater than 0 to less than 0. So whenever the slope of the tangent changes from positive to negative, then x equal to minus 1 is a point of local maxima. And that is very sure. Now, to find out the maximum value of the function, what we do is we substitute x equal to minus 1 in the expression of the given function. And when you do that, you'll find that the value of the function at that point is equal to 5, and 5 is therefore a maximum value, a local maximum value. So we do again the same thing to the number x equal to 1. We assume that we are taking a number on the left of 1, just lesser than 1, little lesser. So that number on the left of 1, a number little lesser than 1, if we take that number and substitute in the expression of f prime of x, you'll find that the value of f prime of that number will be less than 0, which means that the slope of the tangent is negative, which means that the angle of the tangent with the x-axis is an obtuse angle. Also, if we take a number on the right of 1, just greater than 1, little greater, you'll find that f prime of that number will be greater than 0. So whenever the slope of the tangent changes from negative to positive, we understand that x equal to 1 is a point of local minima. And therefore, the maximum value of the function you can find out simply by putting x equal to minus 1 in the given function. And you'll find the local minimum of the function, it is equal to 1. To supplement your understanding, let us use this table which is on the screen. So you have a number minus 1, and you are taking a number on the left of minus 1. Say you are taking minus 1.1, and that number, when you substitute in the expression of f prime of x, you'll find that the value will be greater than 0. And when you take a number just greater than minus 1, that can be minus 0.9, for example, and substitute in the place of x in the expression of f prime of x, you'll find that f prime of minus 0.9 will be less than 0. So the slope of the tangent changes from positive to negative, which means that x equal to minus 1 is a point of local maxima. And the same thing we do to a number x equal to 1. Say we take a number on the left side of 1, it can be 0.9, for example, and 0.9, when you substitute in the expression of f prime of x, you'll find that the value of f prime of 0.9 will be less than 0. And say you're taking another number which is on the right of 1, say 1.1, and you will find that f prime of 1.1 is greater than 0. So the slope of the tangent changes from negative to positive. Therefore, x equal to 1 So the slope of the tangent changes from negative to positive, and therefore we understand that the value of x equal to 1 is a point of local minima. And remember, we use the word local because we are not considering the whole x-axis. We are taking only some portion of the x-axis, and therefore we use the term local. And when you consider the whole x-axis, then maybe the maximum value and the minimum value of the function may be different. So that is all about finding the point of local maxima, local minima using first order derivative.